Welcome to the very last video for our unit. In this video, we're going to solve problems with quadratic functions. So there are a few steps that you can follow as a guideline to help you solve for these word problems. The first thing you want to do is set up your variables. So that's usually your x and y. What does x represent and what does y represent? Then you want to set up the quadratic function depending on the question. Once you have the quadratic function, you can complete the square and find the vertex. When you find the vertex, the y value is going to be your max or your min, and your x value is when that max or min has been reached. So for this first example, Seth has 50 meters fencing to enclose a rectangular area. Just going to draw a picture on the side. Pictures is also a good resource, so if you draw your picture, kind of label its sides, then it'll probably give you a better idea of how to create your quadratic function. So I do even suggest, as your in-between step from 1 to 2, to draw a picture. It's not all the time, but sometimes it's very helpful. Okay, and then we're talking about the area. So area is usually calculated by length times width, or in this case you can say x times y. And then we can say, this will be from our first step, x can be our length and y can be the width. We want to find the maximum area that can be enclosed, and we want to find those specific dimensions. Well, we need to create a quadratic function. There are some things we do know right now. We have information that we have 50 meters of fencing, which also means your perimeter, because we need to enclose this fence with 50 meters of material. So that means if I want to solve for my perimeter, that's 2x plus 2y is 50, because I have 2 widths and 2 lengths. Now I could also rewrite this and maybe solve for either x and y or y. So let's just say we're going to solve for y. I'm going to move my 2x to the other side, which is 25 minus x. So I just rewritten this 2x plus 2y equals 50 into y equals 25 minus x. And we're going to see why in a moment. The next thing I'm going to do is write an equation for the area. So area is length times width, or x times y in this case. I don't want two variables though. I can rewrite my y as 25 minus x, because we just found that in step 2. And now this looks like a quadratic, and we need the vertex for this. In other words, we have minus x squared plus 25x. In my next step, I'm going to complete the square to find the vertex. So to complete the vertex, I can't have a coefficient in front of my x squared, so I'm going to factor that out. Then in my next step, I'm going to take this 25, divide it by 2, and then square it. And I also need to subtract that out as well. Now I want to simplify this a bit. I can pull this guy here out, and if I do that, I have to reverse the fact that I factored it. So we're going to multiply then this negative and this negative here, and it becomes a positive once it's outside the bracket. Now I'm going to combine our large bracket here into its factored form, which is minus 12.5 squared. And then I can simplify this 25 over 2 squared. And if you put that in your calculator, that will be 156.25. So then our vertex is 12.5, 156.25. So our x value is 12.5, and our y value is 156.25. And that is our answer because we want to find the dimensions. So that is your length. 12.5 is your length in meters. And your width, which is y, is going to be 156.25 meters. Second question. You have two numbers that have a sum of 20. Does the sum of their squares have a minimum or a maximum? And then we want to determine those numbers. This one we can't really draw a picture for, but we can state that x is number 1, like the first number, and y can be the second number. Then we know the sum, if we add them together, is going to be 20. I can rewrite this as y equals 20 minus x. And we're going to do something very similar to the first example. The other equation I have is the sum of their squares. So that's going to be x squared plus y squared is either a maximum or a minimum. I'm just going to call that as m for our max or a minimum. I just wrote that y can be 20 minus x. So I'm going to replace y with 20 minus x. Now I'm going to expand and simplify and then complete the square. So if I simplify this, I'm going to get 400 minus 40x plus x squared. Just as a side note, in case you forgot, this is 20 minus x times 20 minus x, which is why I have 400 from the 20 times 20. Then I have 20 times negative x, another 20 times negative x, added them together is negative 40x, and then negative x times negative x is positive x squared. Now I'm going to combine my like terms, so this will be 2x squared minus 40x plus 400. My next step is to complete the square. So I'm going to factor out the 2 because we can't have a coefficient next to the x squared, which means this 40 becomes a 20. And I don't care about this 400, I'm going to leave this on the outside and not factor it at all. Now I'm going to divide this 20 by 2, which is 10, and then square it, which is 100. And I'll also subtract that as well. I'm going to pull this negative 100 out, and when I do, I need to reverse the fact that I factored it and multiply it by 2. So I'm going to add 200 outside of this bracket. Then I can factor my x squared minus 20x plus 100. This is x minus 10 all squared. Then I'm going to simplify the 400 negative 200, which is 200. So we finished completing the square. And if you think about the characteristic of this form, we're going to have a minimum because we have a positive a value here. So that means that our arms are going to face up. So this is a minimum. Lastly, we're going to state what that minimum is for those numbers. So x is equal to 10. X is equal to 10. So if we want to find y is determined by 20 minus x, and we know what x is, and that's 10. So y is also 10. And these are your answers. For example number 3, an apple orchard has 20 trees per acre. The average yield is 300 apples per tree. It is estimated that for every additional tree per acre, the average yield per tree is reduced by 10 apples. How many trees per acre will yield the largest amount of apples? All right, so it seems like it's kind of confusing, but again, we're just going to break it down into its parts. We're going to determine what x and y are. So let's just say x is the number of trees. And then y would be the largest amount of apples. Then our next step is to create the equation. So if we just think about the trees per acre, it says we're going to have 20, but we could also increase those amount of trees. It says it's estimated for every additional tree per acre, then we know that the average yield is going to reduce. So if we just focus on the trees per acre, we have 20 trees per acre, and then we can add each additional one. Then the next part is the average yield. We know the average yield is 300 apples per tree, and it can be reduced by 10 apples depending on how many additional trees we add. So we're going to start with 300. We know we're going to reduce 10 apples for every additional tree per acre. And the additional tree is x for the number of trees that we add. Now we want to expand this and complete the square to find the maximum. So we're going to expand this first. 20 times 300, 6,000, minus 200x plus 300x minus 10x squared. I'm just expanding the equation we just found. And then I'm going to simplify. So we have negative 10x squared plus 100x plus 6,000. Now I'm going to complete the square. Factor out the negative 10 in the front. Then we're left with negative 10x. I'm going to leave the 6,000 on the outside. I'm going to divide 10 by 2 and then square it, which is 25. I'm going to add 25 and subtract 25. I'm going to pull this 25 out, but when I do, I'm going to multiply it by negative 10. So negative 10 times negative 25 is going to be positive 250. Then the last thing I'm going to do is factor. So this is x minus 5, all squared, plus 6,250. So step 4, we're going to read off our vertex. So x is 5 from our vertex, and this is the number of additional trees we're going to add. So we have 5 additional trees. And if we want to know how many trees per acre will yield the largest amount, trees per acre is calculated as 20 plus x, because we stated that right here, which means this is 25 trees per acre. And that's it. Last example is number 4. A parking pass costs $20. At this price, 150 students will purchase passes. For every $5 you increase in price, 20 fewer students will purchase passes. We want to know the maximum profit, and we also want to know what is the maximum profit. So what price will give us the maximum profit, and then what is it? The first thing we're going to do is state our x and y. So x is the number of increases, so every 5 increase in price. So number of increases of $5, y is going to be the profit. And then we want to set up our equation. So we are looking for profit, so that's y. Now we know the cost of the parking pass is $20, and we can increase this by $5 each time, but we don't know how many times we're going to increase this by. This is the price of the pass. Then we're going to multiply it by the number of students buying. So that's going to be 150 students. It says 150 students will purchase this pass, but we know that 20 fewer students will purchase the pass for every increase. Okay, so now we have our equation, our quadratic equation, and then we're going to simplify this by expanding. So 20 times 150 is 3,000. Then we'll do 20 times 20x, 5 times 150, 5x times 150, and then 5x times negative 20x. So we'll go ahead and do that calculation. And then simplify. Okay, and then step 3 is to complete the square. So I'm going to factor out the negative 100 in the first 2 terms. What I'm going to be left with is 3.5, and it would be negative 3.5. You would just do negative 100, take this negative 100, and then you're going to divide it with the 350. I'm going to leave the 3,000 alone on the outside. Okay. Then I'm going to take this 3.5, divide it by 2 and square it. You may use your calculator to help you out with this. It's going to be 3.0625, and remember to subtract that as well. I'm going to bring this negative 3.0625 on the outside, and I will have to multiply it by the negative 100 to undo the factoring. So I'm going to have 306.25 on the outside. Remember, you are multiplying this negative 100 and this negative 3.0625 to get this positive 306.25 on the outside. Then finish this off. So we're going to factor, and we'll get x minus 1.75 all squared. Then we're going to combine what's on the outside. That's 3,306.25. So that means x is 1.75. This is how many times we're going to increase our price by $5. So now, going back to A, we're looking at the price per pass, which is calculated, and we have this up here as 20 plus 5x. We already calculated the x is going to be 1.75. So then your cost of the pass is going to be 28.75. Lastly, we want to find the maximum profit. And when you calculate the max profit, we're going to insert that x value into our y, or in other words, we can look at the y value of our vertex. And that is going to be 3,306.25 is our maximum profit. So this is the y value of the vertex. And we are done, and also done this unit.